Geosynthetic in soil stabilization. Our project for BFC 34402 is to review study of soil improvement case studies. We have to find at least 5 articles or journals that highly relates to the topic and review 3 case studies. What is geosynthetic? Geosynthetics are materials made from various types of polymers used with geological materials such as soil and rock. Geosynthetics are to enhance, improve, or modify the behavior of various civil engineering works. Geosynthetics are available in a wide range of forms and materials, each to suit a slightly different use. These products have a wide range of applications and are currently used in many geotechnical, transportation, hydraulic, and private development applications, including roads, airfields, embankments, retaining structures, reservoirs, canals, dams, erosion control, sediment control, landfill liners, landfill covers, mining, and agriculture. Geosynthetics can be classified as follows. First, geotextiles. Second, geogrids. Third, geonets. Fourth, geomembranes. Fifth, geosynthetic clay liner. 6. Geocells. 7. Geoform. And 8. Geocomposites. Geotextile. Geotextiles are permeable fabrics which, when used in association with soil, have the ability to separate, filter, reinforce, protect, or drain. Geotextile is the most widely used in geosynthetics. Geotextile fabrics come in 2 basic forms: woven and non-woven. Geogrids. A geogrid is geosynthetic material used to reinforce soils and similar materials. Geogrids are commonly used to reinforce retaining walls as well as subbase or subsoils below roads or structure. Load is distributed evenly after the use of geogrid. Geonets. A geonet is a geosynthetic material consisting of integrally connected parallel sets of ribs overlying similar sets of various angles for in-plane drainage of liquids or gases. Geonets are made of stacked criss-crossing polymer strands that provide in-plane drainage. 2 layers of strands are called biplanar, while 3 layers are called triplanar. Geomembranes. A geomembrane is a very low permeability synthetic membrane barrier used to control fluid or gas migration in a structure or system. It is normally used as a fluid barrier in designing a drainage system and also as a dam-proof course in floors or roof. Case study 1 is about the field instrumentation and monitoring of soil erosion in core geotextile stabilized slopes. This highly erosion-prone hill slope is located in the Attapadi region of Kerala. About 5,330 million tons of soil is being lost every year due to urbanization. Conventional methods have been used, but it is not suitable in steep slopes, which are highly susceptible to erosion. Thus, natural and biodegradable fibers, which are coir and jute, has been used, which lead to aid in vegetative turfing along slopes. In application of soil control, the coir netting shields the soil and seeds from impact of first, raindrops, second, minimize the runoff, third, maintain the capacity of soil to absorb water, fourth, to retain the soil moisture, and lastly, holds the soil particle and seeds in place. Next is our case study 2 is about the improvement of granular subgrade soil by using geotextile and jute fiber. It is located in the Padma River at Talaimari, Rajshahi, India. The soil at the Padma River has a very low bearing capacity. Thus, the hosine, which is the current research works, are mainly emphasized on improving the strength of mechanism and bearing capacity of the reinforced soil by adding jute fiber and geogrid. The results from the installation of jute fiber, the California bearing ratio value increases with the increase of both fiber content and aspect ratio. The test shows that placing of geotextile at top is more effective than placing it at the middle or at bottom. Also, the increased layer of both geotextile and length, and also the percentage of jute imparts increasing the bearing capacity to the granular subgrade soil. The combination reinforcement with single layer geotextile with only 0.5% and 1.0% of jute fiber is as effective as 2 or 3 layers of geotextile. Lastly, case study 3 is about the effect of geosynthetics on the performance of road embankment over subcast soil in Algeria. It is located in the subcast soil of Chott El Hoda in Algeria. The challenge is to design and construct a solid road foundation on top of a very soft soil. Before the reinforcement, a test was conducted in order to analyze frictional characteristics of sand geotextile and subcast geotextile sand interface. Therefore, the study on the advantage of geosynthetic reinforcement is uses in the construction of road embankment. The uses of geosynthetic reinforcement are: first, to minimize differential and total settlements; second, to improve the bearing capacity of soft subsoil; third, to prevent contamination of the base materials, allowing for more open-graded, free-draining aggregates; fourth, to reduce the pavement thickness; and lastly, to extend the service life of the pavement road. From the results, it shows that the bearing capacity of the weak subgrade was improved when using the geosynthetics in reinforcement for unpaved road. Based on the data analysis, the effect of geosynthetic on the improvement of bearing capacity for the reinforced increased compared to the unreinforced result. When the bearing capacity was improved, the value of undrained cohesion also increased and it becomes negligible for the subgrade. Thus, the subgrade can resist the applied loads. For example, the use of geosynthetics in earth retention techniques is retaining walls. Retaining walls are structures designed to restrain soil to unnatural slopes. For heavy loads or for greater slopes, concrete walls are placed along with the use of geosynthetic. The geogrid ties the portion of stable earth with the unstable earth. The geogrid is laid in layers within the earth fillings in between. Mostly, after a period of 1 to 2 seasons, the growth of vegetation takes place, making it look like a natural landscape. This is an example for the simulation of soil without geogrid.
Dah. Kuat. Dah. Tak boleh lebih jap semula.
Without geogrid, when the load is applied to the soils will easily move and fill. But when the geogrid is installed, the soils will not move and will maintain its condition even when the load is applied. This is because the geogrid ties the portion of stable earth with the unstable earth. This is an example simulation of a channel without geomembranes.
Seru tak? Dah. Tak seru sangat ya? Okey, no. Bagi lalu kan?
Without geomembrane, the soil erosion is easily to occur when the water flow through the channel. But when the geomembrane is used, it will act as a fluid barrier in a channel system, and it can avoid the soil erosion from occur. In conclusion, any permeable textile materials used for the separating, filtration, reinforcement, protection, drainage, and stabilization process are an integral part of civil engineering structures of earth, rock, or other constructional material are called geotextiles. Geotextile is one of the methods that can be used and need to soil improve, such as stabilize and pavement construction. Geotextile has been practiced for a very long time in soil improvement. However, the advance in manufacturing and marketing has led to innovative uses of geotextile in soil improvement in the recent years. These included by the cases that we find related to these geotextiles, which is, in case 1, coir geotextile has been used to propose and to stabilize the soil in slopes, while for case 2, the soil need to be emphasized on improving the strength mechanism and also the bearing capacity by adding the jute fiber and geogrid. Lastly, for case 3, the type of soil is subkarst soils, which are coastal and inland saline deposits that are formed in arid regions. These 3 cases is examples of geotextile that can be used to improve the soil improvement stabilize the soil, and pavement construction. The future of the geotextile seems limited only by human imagination.